Assalamualaikum warahmatullahi wabarakatuh. My name is Werkazer Bagaskara. I'm here with my friend Ibnu Risman Farel and Ahmad Ishamohono. And here's our IoT vinyl project about the vehicle speed monitoring system. So here is the first slide about our team performance. I'm here as a manager that is manage the team goals and submit the team reports. And my friend Ibnu Borisman Varal as a programmer. He's programming nodes and router in CapCarbon and programming the vehicle route and programming the master receiver. And my friend Ahmad Ishamohono as a designer is design the overall IoT network design and the sensor node and the communication protocol. Next is about the speed limit. Speed limit are set with the goal of keeping everyone safe. The limit are designed on what is believed to be the safest speed for the flow of traffic and the safety of drivers, passengers, bicyclists, and pedestrians. They are typically set on the basis of what 85% of drivers will comfortably drive on their own without posted limits. General roadway guidelines apply in all states to help determine the speed limit. Like the arterial roadways, like interstate, have the views access point and can sustain the high speed. Next is the collector roadways, such as the country road, and balance higher speed and more access point. That one is the local roadways, like the neighborhood street, that have the low speed due to the higher number of access point. Next is about our project. The project is to create a simulation of a pacing vehicle speed detection system in CapCarbon application. The team successfully created a speed detection system for one pacing vehicle. The system is able to detect if the pacing vehicle is speeding over the speed limit in that certain area. The project is built on top of Yogyakarta map area near Gajah Mada University, and the project is still under development with more sensor nodes to be added to the street of Yogyakarta. Our target is this project is to propose and develop a new smart vehicle overspeeding detection using the IoT technology. For alerting information about overspeeding vehicles, the smart vehicle overspeeding detector is very essential for the human life as there are so many accidents in the road every day. The benefit of this project is to make roads safer and more data and collecting more data on how human drive.
So how it works is by having sensors in the streets where vehicle passing through a restricted speed area such as school zone. The sensor picks up signal from the speed from the vehicle and sends it to multiple router from it to reach its main center. The main center then sees which car is speeding from the data received and do further investigation on the vehicle using CCTV camera helps detect and identify the type of vehicle and the number plate. By using IoT, we can also have each the device or the vehicle has its own unique ID. The communication protocol that we use is MQTT, which is an OSIS messaging standard for Internet of Things. It is intended to be very lightweight, publish and subscribe messaging transport for connecting remote device with a small code footprint and low network bandwidth. MQTT is now used in wide range of industries, including automotive, manufacturing, telecommunications, oil and gas, and so on. We use MQTT because of its lightweight and efficient. It can do bidirectional communication. It is reliable enough to deliver a message, and it can easily encrypt a message using TLS, and it supports unreliable network. So the system design is by using a speed sensor that connects to a router. In this case, the speed sensor it's in each vehicle. So the main sensor can then determine if the vehicle is speeding or not, and then could maybe send it to the police department or other department that will benefit from the data. So first one is start. So vehicle passes through the first sensor, and then a counter starts, and the vehicle passes to the second sensor. The counter stops and calculate the time between the sensors and calculate the speed of the vehicle. And then the speed limit exceed, it can goes to the fast route or send information to the post department. So the problem we faced is on week one, we having the sensors to detect the moving vehicle when it reach the area is a little bit difficult on Cap Carbon, since the sensor itself, we cannot like program it to detect when a moving passing vehicle passes through. So the solution to that is by programming the vehicle. So the vehicle has its own speed sensor that sends to the router on the road. On week two, the team encountered problem when adding more vehicle to detect. We are still finding solutions to be able to detect more than one vehicle speed at the same time on the same sensor node. So on the real world, we ideally we have a lot of vehicles, and we want to detect each and every one of those vehicles and send the speed into our main center through the router. So the solution is to create another route for another vehicle. But we will see in the next simulation on how we or our solution to the problems.
Okay, so moving on to the carbon simulation. So this is our design of the carbon simulation, where we have our first route, which is near the Pogong area. And then we have our nodes, our router, which is placed on 2 points. As you can see from the left to the right, there's some distance, and there will be a passing vehicle. And then this router will send to another router, which then at the end, it will send to the main center. And then this is the result when a vehicle is passing through a router. Back. Over here, as you can see, the speed of the vehicle is at 37 kilometers per hour. And so I've set the speed limit for this road or street to 45. So as you can see, when the vehicle is passing through the first router, it says safe on the main center. So it does not yet exceed the speed limit. And then next, as you can see here, it overspeeds because the speed is at more than 45. And here is the code behind it all. So the first we have the router code, which I used from the template using the Cap Carbon, where it receive and read the data of the variable X, and then it sends to the next router. And then we have our receiver, which is our main center, where it receives the data from the router. And I've said before that if I set the speed limit to more than 45, so if X is more than 45, it will print overspeed, mark X, or else it will print safe, so it doesn't overspeed. And then we have the vehicle itself. I've set the X to first at 30, and it will print the speed of the vehicle when the vehicle is moving, and then it will send the data to the router. I've also set the x plus 1, so every time it moves, it adds by 1. So to show that the vehicle is moving at a fast pace. So now I'm going to show the simulation. Okay, as you can see here, this is our simulation. It is different from what we have from the slides, but it is actually the same, where we add more nodes and routers, and also we add 2 vehicles. So when we play, as you can see, vehicle 1 is passing, which is the bottom, which is at a slower speed than the vehicle 2 on the right. So let me start again. First, we focus on vehicle 1. So as it passes through the first sensors, it's safe because it has not yet passed the speed limit. And then as it goes by, it will pass the second router where it exceeds the speed limits, and the main center will detect it and will say overspeed. And then we can start again and focus on the second vehicle. As you can see, it already passes the speed limit from the first road. Let me just complete this simulation. So again, it detects the first vehicle, which is overspeeding at the Kaliurang Street. Okay, I think that's all for the simulation. I will give back to my manager, Barik.
So yeah, I think that's all from our group. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.